Welcome back. The objectives of this video are to evaluate trig functions of quadrant angles, or quadrantals as you'll hear me talk about them, and we'll also use some trig identities. You may recall in the last video we evaluated trig functions and we calculated what our x value was equal to, our y value, and our r value. And depended on the point and which quadrant we were in, what our x, our y, and our r's were. Now our r was always our hypotenuse, and that was always positive. But when evaluating quadrantal angles, we don't have a hypotenuse. Recall that when we had reference angles in the last video, we drew a triangle, we created a right triangle, and then we had a reference angle. And so we had our x value, our y value, so here our y would be negative, and our r value, or our opposite and our adjacent and our hypotenuse. But when we're on the quadrantal, you know, that triangle keeps moving, okay, and that hypotenuse changes, and finally, as that triangle comes around, all of a sudden, we don't have a hypotenuse anymore. We have an x and a y, okay, and an r, but there's no triangle here anymore. So our r value becomes whatever length we have along the x or the y axis. That becomes the length on whichever axis we happen to be working on. Well, what we're going to choose that length to be, we can let it be anything we want, but to make our life easy, it's going to be 1. So again, we can refer to our unit circle here, which is a circle with a radius 1. Well, we can use our unit circle values to evaluate our quadrantals. So at pi over 2 or 90 degrees, our x values were, or our ordered pair was 0, 1. At pi or 180 degrees, our ordered pair was negative 1, 0. At 3 pi over 2 or 270 degrees, our ordered pair here is 0, negative 1. And then back at 0 or 360, our ordered pair was 1, 0. So we could use anything we wanted. We could use 5 here, or 10, or negative 100, but it makes sense just to use 1. So the sine of pi, well, sine is the y value. Pi over here on the negative x-axis, so the sine of pi is simply equal to 0. The cosine of negative pi over 2, that's going to put us down here at the ordered pair 0, negative 1. We wanted cosine, that is the x coordinate at that point, and that point is 0. The tangent of 0 degrees, now remember tangent is y over x. So our y value is 0 and our x value is 1. So the tangent of 0 is 0. And of course that would be the same as the tangent of 360, wouldn't it? They are coterminal. And then the secant of pi over 2. So pi over 2 puts us at essentially 90 degrees, or at the ordered pair 0, 1. And secant is the reciprocal of cosine. So we know cosine is equal to our x value, or 0. So the secant is, well, we'll call that cosine 0 over 1. So our secant would be 1 over 0. The secant is undefined at pi over 2. So we would want to say undefined there. In fact, you will see here that any of our quadrantals, our values will only be either plus or minus 1, 0, or undefined. Those are the only options for our quadrantals. Objective 2, using our trig identities. Sample 2 says, let theta be an angle in quadrant 2 such that the sine of theta equals 1/3. So our y is 1, our r is 3. We're in the second quadrant, so x's will be some sort of negative value. So our sine, our opposite over our hypotenuse, is 1/3. Find the cosine of theta using trig identities. Well, I've got cosine and sine here, so I'm going to try and tackle this with the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. And I've got the sine is 1/3. So 1/3 squared plus cosine squared theta equals 1. 1/3 squared is 1/9. I'm going to subtract that 1/9 from both sides. And I get cosine squared theta equals 1 minus 1/9 is 8/9. I want to find the cosine, so I'm going to square root both sides. I get the cosine of theta equals the square root of 8 over the square root of 9, or 2 square root of 2 over 3. And be careful here. We think we're done because we've got 2 square root of 2 over 3. However, we are in quadrant 2. So we're in quadrant 2. X is negative, which means our cosine must be negative. So our final answer is actually negative 2 square root of 2 over 3. That is our cosine of theta. So be careful, watch out for that. Make sure you know what the sine is. Remember, trigonometry is a lot like real estate. Location, location, location. Where are we at? So that wraps up this video on finding the trig functions of any angle and an example using trig identities. And you'll get some more practice with this when I see you in class.